Okay, guys, now that we have learned all about integers, we're going to move to another subset of the number system, and that is rational numbers. But remember, no calculator for this unit. Also, pausing the video as you need. Rational numbers are the set of numbers that are fractions whose numerator and denominator are integers. Remember that no denominator can be a zero. In the word rational, we can see the word ratio, which is a way that we can write a ratio like a fraction. So ratios can be written as fractions. Therefore, any number that can be written as a fraction or a ratio is a rational number. Remember, a rational number can be written as a fraction whose numerator and denominator is an integer. And we've already talked about what an integer is. It is our positive and negative whole numbers. Recall the number system of integers includes the counting numbers, whole numbers, and integers. Where the counting numbers are the innermost set, they are the most restricted, the smallest set, and integers are the outermost, which is the least restricted. They are the largest set. So with the three sets we have learned in this unit so far, we have the counting, the smallest set, and then we move to whole and then integers. Now we are adding on to this, and when we add the rational numbers, we're going to see that those include our fractions and decimals. So once we add the rational numbers, and they are included in the number system, the rational numbers become our least excluded and our largest set. So rational numbers include the fractions, integers, whole numbers, and counting numbers. Here are some different categories of rational numbers. We have our fractions, so we can have a proper fraction. We can have an improper fraction. We can have a mixed number. We have a terminating decimal. We can have a repeating decimal. We can have percents. These are rational numbers. Our integers are rational, our whole numbers, and our counting numbers. These are all rational numbers. So let's talk about repeating decimals. Is a digit that keeps repeating and goes on and on forever. So here our 2 is repeating and it does not terminate, it doesn't stop. Here, 0.5 repeating means the 4 and 5 keep repeating on and on. These repeating decimals are rational numbers. Terminating decimals means that it comes to an end, the word terminate, to end. 9.23 or 9 and 23 hundredths. The number stops. This is a rational number, as well as this negative 0.7153. It comes to a stop. It is a terminating decimal. Therefore, it is rational. So pause the video and classify these numbers before we move to the next part of the lesson. Okay. Recall if a number can be written as a ratio or fraction, whichever term you like, it is a rational number. The following are the processes to convert numbers to fractions to verify or prove that the number is indeed rational. So sometimes you'll be asked to classify, but then prove that it is rational by creating the number into a ratio. So when we have an integer, we just place that integer over 1, showing that it is a rational number. When we have a terminating decimal, we can just read it, 8 3/10. It's in the tenths, the 3 is in the tenth space. Then a percentage, we simply move the decimal, it's understood to be at the end, we move it over 2 places to the left, and then we convert that by saying 17 hundredths. Here we have a ratio, a fraction. Example number 8, here we have an integer, we can place it over 1. 0.25 or 25 hundredths, we can simplify if we want to. Negative 8 so I have negative 8 1/10. And then example 11, we have 2.3%. We move the decimal 2 places to the left, and it becomes 0.023. And the 3 is in the hundredths place, so 23 thousandths, in the thousandths position. Pause the video, classify these, and convert to show that these are rational. Okay, using a number line is helpful when comparing numbers. So using a number line, having that visual is very helpful when comparing the numbers. Remember, the numbers to the right, let's say this, the numbers to the left are smaller than the numbers to the right. So if we have 2 and we're comparing it to the 0, 2 is to the right of 0, therefore 2 is greater than 0. So when we are going to compare rational numbers, converting the rational numbers into decimals is a common practice. So if we have fractions, because decimals are rational numbers too, but if we start out as a fraction and we want to convert them to a decimal, it's easy to compare. Converting rational numbers to decimals is a common practice when comparing and or ordering numbers. To compare decimals, we simply line up the decimal point, and then we will compare the numbers from left to right. But guys, we have to be super careful when we compare negative numbers. Remember, the word negative means opposite of. So sometimes what I do is I'm like, okay, if these, like when we get to number 14, these are negative, but if I compared it as though they were positive and then just change my answer to the opposite, then I have it correct. But let's get there. So 0.75 compared to 0.705, we're going to line up the digits. And we're going to start from the left and work our way to the right. So our positive zeros are the same. Sevens are the same. Now we have 5 is greater than 0. So we can pause there and say 0.75 is greater than 0.705. And on our number line, this is 0.75. 0.705 is just right a little bit to the left. So we know that 0.75 is greater than 0.705. Now let's look at our negative numbers. So we have negative 0.75, and we're going to compare to negative 0.705, which is a little bit right here. And we can see negative 0.75 is to the left, therefore it is less than. Okay, now let's see how we can do this when we don't have a number line. So again, we're going to go from left to right. So we're comparing negatives. So I'm going to show you two different ways how you can think about this. So our zeros are the same. We have -7 and -7. Those are the same. Now we have -5 compared to 0, because 0 is neither negative nor positive. So -5 is smaller than 0. We would know -5 on the number line is to the left. So therefore, we do have less than. Another way you can look at this, like I was mentioning earlier, is if I pretended these were both positive, like in example 13, okay, I would know that 5 is greater than 0. So I would say this number is greater than, but then I have to pause and say, oh, but I have negative, so I need to think the opposite of that. So the opposite of greater is less than. Now we are going to convert rational numbers to decimals so we can compare. So an integer to a decimal, we simply just place the decimals at the end. 8.0. When we have a ratio or a fraction, when we want to convert it to a decimal so we can compare, we divide the numerator by the denominator, top in the box. So the top number goes inside the box. So 5 is going to be divided into 3. 5 can't go into 3. It goes 0 times. So we are forced to create a decimal. Now we can look at it as 5 into 30. And 5 into 30 goes 6 times. 6 times 5 is 30. And we get 0.06 or 6/10. Simply to make 17% a decimal, we move it 2 places to the left and we have 0.17. So when we compare these two numbers, they're both positive. We're going to convert them to a decimal and we divide 8 into 3. Again, we're not going to use a calculator. So we're going to have 2.7. So I am going to divide 8 into 3. Eight into 30 goes about 3 times. 3 times 8 is 24. Subtract, bring down a 0. 8 goes into 60. 7 times 8 is 56. Subtract, bring down another 0. And 8 into 40 is 5. So we have 2 and 3, 2.375, and we're going to compare it to 2 4/5. Again, top goes in the box, so we're going to divide 5 into 4.0. Again, we're going to have 2 point something. 5 goes into 40 8 times. So we have 2.8. So we can compare these. The 2's are the same. Then we look at the tenths. 3 is less than 8. Therefore, 2 and 3/8 is less than 2 4/5. Okay, now we're going to do, we're going to take a look at comparing negatives, and we remember we have to think the opposite of here. So let's first convert them to decimals. So I'm going to have, I know my answer is going to be a negative decimal, so I'm going to divide 9 into 4. So now I'll look at it as 9 into 40. 9 into 40 is going to keep repeating, so I have a negative 0.444 and on. And now we're going to have a negative 3/4. Hopefully we know that that is 0.75, but just in case, so 4 into 3, 0 times 4 into 30 is going to go 7. 7 times 4 is 28. And 4 into 20 is 5. So it's negative 0.75. So we compare the negative 4 and the negative 7. Negative 4 is greater than negative 7. Therefore, negative 4/9 is greater than negative 3/4. Okay, now you classify these And then make sure you check the answer key and make any corrections before moving on to the concept check.